Did you know that beneath the barren, red surface of Mars, there might be a secret, hidden world? A world of water, flowing through ancient, subterranean rivers. It sounds like science fiction, right? But recent discoveries are painting a picture of Mars that is far more dynamic and watery than we ever imagined. Today, we're diving deep, literally, into the Martian underground to explore the evidence for these hidden waterways and what they could mean for the ultimate question. Are we alone in the universe? For decades, we've stared at Mars, seeing a desert planet, cold and seemingly lifeless. We've sent rovers to its surface, orbiters to map its terrain, and found tantalizing clues of a distant, watery past. We've seen the dried-up riverbeds, the ancient deltas, and the polar ice caps. All signs point to a Mars that once had oceans and rivers. A planet much more like Earth. But the question that haunted scientists was, where did all that water go? Did it all just evaporate into space, lost forever? Well, the answer might be right under our feet, or rather, right under a rover's wheels. New data is completely rewriting the story of Martian water. It's not just a story of the past. It might be a story of the present. The journey to this discovery began with a technique we use right here on Earth, seismology. Just as earthquakes help us understand the layers of our own planet, Marsquakes are helping us map the interior of Mars. NASA's InSight lander, which operated on the Martian surface for 4 years, was equipped with an incredibly sensitive instrument called a seismometer. Its mission was to listen for the faint rumbles traveling through the planet's crust. And listen, it did. InSight detected over 1,000 Marsquakes, providing an unprecedented look into the planet's internal structure. But some of the most exciting data came from analyzing how these seismic waves traveled through a specific region near the Martian equator, a place called the Elysium Planitia. This is a vast, smooth volcanic plain, and what scientists found there was astonishing. As the seismic waves from the Marsquakes propagated through the ground, they behaved in a peculiar way. In certain areas, they slowed down, and their energy was dampened. This is a classic signature that geophysicists look for when searching for liquids underground. The data suggested a layer of porous, sedimentary rock, like sandstone, filled with something far less dense than the surrounding rock. And the prime suspect? Liquid water. But it gets even better. This wasn't just a small, isolated puddle. The models based on the seismic data suggest a vast network. We're talking about a layer of water-saturated rock, potentially several kilometers thick, buried between 2 layers of impermeable volcanic rock. Think of it like a giant, natural aquifer, a sponge of rock soaked with water, sandwiched between 2 solid plates. So, how deep are we talking? The top of this potential water-bearing layer appears to be about 300 to 600 meters below the surface. That's deep, but not impossibly so. And its volume. Estimates are still being refined, but we could be looking at a reservoir so vast it could rival some of the largest groundwater systems on Earth. If you were to bring all of that water to the surface, some models suggest it could cover the entire planet in an ocean several meters deep. This is a game changer. This discovery fits perfectly with other clues we've seen from orbit. Images of the Elysium Planitia region show features that look suspiciously like channels carved by massive floods. But they seem to appear out of nowhere, with no obvious source on the surface. Scientists have dubbed these Cerberus fossae. One leading theory is that intense volcanic and seismic activity in Mars' past could have fractured the overlying rock, releasing catastrophic amounts of pressurized groundwater onto the surface, carving these giant channels in a very short amount of time. So, we have a compelling story forming. Mars once had a warmer, wetter climate, with surface water. As the planet lost its atmosphere and cooled down, this water didn't just disappear. A significant portion of it seeped underground, getting trapped in porous rock layers and protected from the harsh surface conditions by thick layers of volcanic basalt. It's a relic of a wetter Mars, a frozen-in-time memory of a blue planet. But here's the most exciting question of all. Is this water still flowing? Is this a relic, or an active system? The immense pressure from the overlying rock and the geothermal heat from the planet's interior could be enough to keep the water in a liquid state, especially if it's very salty, which would lower its freezing point. Mars is not a geologically dead world. We know this from the Marsquakes. This internal heat and activity could be driving a slow, but active, hydrological cycle deep underground. Imagine, slow-moving rivers, not in open caverns, but seeping through kilometers of porous rock, a hidden, dark biosphere. This has profound implications for the search for life. Life, as we know it, needs 3 key ingredients: a source of energy, organic molecules, and, most importantly, liquid water. The Martian surface is hostile. It's bombarded with radiation, it's freezing cold, and it's incredibly dry. It's hard to imagine life surviving there today. But a few hundred meters underground, it's a different world entirely. You are shielded from that deadly radiation. The temperatures are more stable. And if our seismic data is correct, you have the most crucial ingredient in abundance: liquid water. On Earth, we have found life in the most extreme places imaginable. We've found microbes thriving deep within the Earth's crust, in complete darkness, surviving on chemical energy from rocks and water alone. These are called Chemoautotrophs. They don't need sunlight. They eat minerals. Could a similar kind of ecosystem exist on Mars, powered by the chemical reactions between the water and the volcanic rock? The possibility is absolutely exhilarating. We might have been searching for life in the wrong place all along. Instead of just scooping the surface dust, maybe we need to drill. Future missions to Mars are now being designed with this in mind. The idea of sending a probe that can drill hundreds of meters into the Martian subsurface, once a far-off dream, is now a top priority for space agencies around the world. Imagine a future mission that drills down and sends back the first sample from one of these subterranean reservoirs. Analyzing that water would be one of the most monumental moments in human history. We could analyze its chemistry, determine its age, and, of course, search for the telltale biosignatures of life, either past or present. Even if we don't find living organisms, finding complex organic molecules would suggest that the building blocks for life were there, that Mars had a habitable environment. This discovery doesn't just reshape our understanding of Mars. It reshapes our understanding of habitable worlds in general. It tells us that a planet that looks dead on the surface could be hiding a vibrant, watery interior. This could be true for icy moons in our outer solar system, like Europa and Enceladus, and for countless exoplanets orbiting distant stars. The habitable zone might not just be about surface temperature, but about the potential for protected, subsurface liquid water. The story of Mars's hidden rivers is just beginning. What InSight has shown us is a tantalizing glimpse into a hidden realm. It's a puzzle, and we've just found a huge, crucial piece. The next steps will involve more advanced orbiters with ground-penetrating radar to better map these structures. And eventually, landers and rovers capable of drilling to reach them. The frozen depths of Mars hold the secrets of its past, and potentially, the key to its future, and ours. Every Marsquake, every seismic wave, brings us closer to understanding the true nature of the red planet. It's no longer just a dusty, cratered world. It's a world with a hidden, watery heart. A world that might, just might, be hiding one of the universe's greatest secrets. The search is on, and the next discovery could be the one that changes everything. Thanks for joining me on this deep dive into the mysteries of Mars. What do you think? Could there be a living ecosystem thriving beneath the red dust? Let me know your thoughts in the comments below. And if you love exploring the wonders of our universe, make sure to like this video and subscribe for more adventures into the cosmos. See you next time.